Okay, we are live. Hi everyone, welcome to the second edition of Coffee and Commits. As a reminder to everyone, these calls are a regular casual catch up with the o1Labs team just to kind of share updates directly with you, the community. These updates kind of give visibility into what's happening across MENA, tooling, ecosystem projects, and just a general look under the hood at what's happening behind the scenes at o1. You don't necessarily see everything, so we just wanted to make sure that we give you a bit more insight into what's happening. The calls are intentionally high level, but you can find deeper dives for most things on our blog or on X. I'll try and share relevant links in the chat throughout the call so you can kind of deep dive into them afterwards. So before we kick off today's call, I will go through the agenda quickly. So we have the welcome and intro. Then we have Nicole, who will join us to share a general update and some of the takeaways from the ETH that we were at last week. Then we'll have Alan join us to share the latest on Mesa Trail. And then we'll have another update from George, who's going to deep dive a bit more into the testing side of things as well. We'll wrap things up with an ecosystem update from Haresh, and then we also have special guests from Zeko joining us today to share more on what they've been up to as well. I'm going to bring Nicole up to the stage, who's going to kick off with the first update. Hey, Nicole.
Hi, Becky. Hi, everyone. Thanks for joining us. So as Becky mentioned, this is our second episode of Coffee and Commits. And I just want to say that I like how this gives us a chance to share what we're working on and what we're learning. There's a lot going on right now. So first of all, our top priority, Mesa, the community incentivized testing is well underway. And I'm going to let Alan speak about that in just a minute. But I wanted to share just how grateful that we are for our community, that they've rallied to give us such great feedback, quickly reporting errors and issues. I also want to thank our team for being so responsive. And lots of activity on Discord and lots of, weekend and midnight hours, both on the o1Labs side and the community side. So just want to say how grateful we are to everyone. So the next thing I want to talk about is ETHConf. We went there in June and we had a big presence there. Deepthi gave a talk called Proof Over Promises, and I'll say more about this in a minute. We had a booth, and I think we had 7 team members there. We also did 3 different demos at our booth. We had one on proof of personhood, verifiable workflows, and verifiable agentic workflows. And we spent a lot of time talking with builders, enterprises, infrastructure providers, and others thinking about where our industry goes next. One thing that stood out is how the conversation around ZK continues to evolve. We did notice there are a number of ZK companies that have actually pivoted into other things, but there's still a lot of people interested in it. And the focus has shifted. So a few years ago, first it was privacy, and then it was blockchain scaling. And now increasingly we're seeing interest in how cryptographic proofs can make real world systems and operations more trustworthy and verifiable. And this is interesting because this is a space we've also been exploring a lot recently. And we think that ZK can be used to provide greater security, verifiability, auditability, composability, and privacy to enterprise systems and processes, both systems that are attached to blockchains and even not attached to blockchains. And this is part of what led us to start thinking about a framework that we've been exploring internally, and now we're starting to talk about externally, and it's called ZK gated execution. And basically, at a high level, this is the idea that before a high stakes action or operation can happen, such as a transfer of digital assets, there should be a cryptographic proof that required rules, checks, or internal processes or policies were followed. So another way to think about it is today, a lot of systems operate on processes and promises. There's a policy, and then there's a claim or promise that a policy was followed. And then there's a system that records that some sort of approval or action happened. But you don't actually know if the policy was followed. So with ZK gated execution, the goal is to move towards proving that the intended policy or required action or check took place. And that's what Deepti's presentation focused on, proof over promises. We think this is a natural extension of what zero-knowledge technology enables. So rather than just proving blockchain state, we think that we can prove operational decisions were made correctly before they happened. So we're still very early in exploring this space, and we're actively working to validate our hypothesis. We're talking to potential customers and users. We're mapping workflows and testing our assumptions. And just want to say that we're exploring this with an open mind and starting from a conviction that verifiability is valuable, and now we're working to validate that hypothesis. And so, yeah, we don't have all the answers. I think some of our assumptions will be validated and some will change, and we may be wrong in some cases, and that's just part of the process. But we're really focusing on trying to understand the problem deeply so that we can identify the right solutions. And I guess I would also just say that we want to continue pushing the practical applications of verifiable computation and bring the expertise our team has built over the years of working with Zeko to solve real-world problems. So we'll continue to share what we're learning and what we're building in the coming months. And if you're part of the community and think there could be a use case for your business or industry, please reach out. We're actively looking for customers and actual workflows to test. Okay, thanks everyone for joining. And now I'll hand it over to Alan, who will share more about our progress with Mesa.
Okay, can everyone hear me? We good? Okay, I think that's a yes, so I'll go ahead anyway. Thank you very much, Nicole. Hi everyone. Anyone that doesn't know me, my name is Alan. I'm an engineering manager at o1Labs. o1Labs, Alan on Discord, for some of you that might have worked with me before. As Nicole already said, thanks for coming everybody. This is really cool. I'm really excited to talk to you about all the cool stuff we've been doing with Mesa. So just a reminder for anyone that's not aware of what the Mesa Trail is, as Nicole mentioned, it's an incentivized testnet to test the Berkeley to Mesa upgrade. So today, going to tomorrow, to the future, in a distributed real-world environment across multiple geographic locations. So it's like a beta upgrade, I guess. So lots of things all rolled into one. So for now, it's been running for almost 3 weeks, and it's on track to finish up by next Monday, the 22nd. And we've accomplished quite a lot with the help of our participants. I'll go through some of that stuff now. So we have 39 community node operators who are being extremely helpful. They're helping us to run all our tests. This is across like multiple operating systems, as I said, multiple geographic locations. So it's giving us a real kind of a good sense of what our user base can be or could be, and helping us to isolate and, I suppose, highlight any issues that may kind of pop up for specific circumstances that we might not find in our own testing. So we're focusing on the upgrade process, and process here being the operative word. It's not just about does the software work, but it's about does the entire user experience work, like our documentation, our comms, our support, because we want to make sure that everything is as good as it possibly can be by the time we want to release it to the world. We did get a lot of valuable feedback. We had a lot of very helpful issues were discovered. Not huge code defects, which is good to see because we've done a lot of prior testing. A lot of issues related to usability. As I said, like even in terms of our upgrade process, and a big thanks to everyone who participated on Discord for helping us to investigate these issues and for your patience in that matter too, because I know a lot of time we had a lot going on at once, and we do appreciate all the effort that people put in there. We validated the automated and legacy upgrade process. The auto mode upgrade, it's a new component in the Mesa era and one of the main features that we're shipping as part of this hard fork. And we want to validate as much as we possibly can in a real world environment. And this allowed us to do just that. We've ran through testing with this on several times. We're going to do it once more. I'll mention that later. But it's given us a real good kind of feel and sense that this is a really good application and it's really stable. Various experiments and load tests complete. As we mentioned before, we ran a lot of different tests, as well as contingency tests around like emergency hard forks, type of chaos test that we probably won't encounter, but it's good to have tested if we do, basically. And people were very accommodating for that on the plan. George is going to talk more about the testing later, so I won't deep dive on that. The emergency hard fork drill, that was one that was successfully completed, and we will be doing another one of those before the program finishes on next Monday. I'll just briefly cover that later, but it's not a big thing. It's just going to give us an extra layer of confidence. So monitoring is obviously ongoing throughout the whole process. We're making sure our network is robust, consensus performance, all of the things we care about in the network, that we're not seeing any dips, we're not seeing any issues that require investigation. If they are, of course, we investigate, but thankfully we haven't seen that, and that's after very, very extensive load testing as well. So we're very happy about the kind of robustness and reliability of the Mesa node. So in terms of next steps, where are we now? Like, we're only a couple of days away from finishing this. So basically, one of the things we want to do is have an open retro with the community. Like, we've had so many people putting effort in this, so we want to get their feedback, which we will do by, I think it's a form, which we'll hopefully send out by the end of this week. And that will allow people to give a good chance to give their feedback, how they felt about it. And as I said, again, we're not just caring about the software. We want to know, like, how is our level of support? Did our documentation make sense? Was it confusing? We want to hear everything. We want to hear, like, all the good, all the bad, so that can make us better, basically. And we're really relying on that. And then we'll have a wrap-up call, I believe, next week, where we can talk through some of these points and, show you as well what we intend to do about them. Because, as I said, we really do care about this feedback. I mean, if we're not going to do anything, it's kind of pointless. So we're obviously going to take it on board. And thank you for that. So, as I said, there's one last hard fork experiment. It's scheduled for this weekend. I think the builds should be out today, all going well. I haven't checked now, but that should be on target. So basically, this will be the last release candidate that has like a roll-up of all the bug fixes, usability issues that have been discovered throughout the MUT so far. So this means this is kind of like hopefully our gold release, that we run through the final kind of paces around one last emergency hard fork test, as well as all our cluster testing, load testing, to make sure that this is good. We're not discovering anything else. If we do, of course, we have to fix them and we have to release another RC, but we have a high degree of confidence that everything we have in now should be enough for us to get to Mesa and do so, safely and successfully. And yeah, very important one, set a date for the DevNet upgrade. Once the MUT is over and everything is looking good, the next step will be, of course, to decide, okay, when can we ship this to the world? When are we going to fork DevNet? Because that's our real kind of I suppose, sorry, I can't find the right idiom, but it's basically when it gets real, when it's in our semi-production stage or staging environment. People get to look at it, exchanges get to look at it. We have outreach where we ask people to make sure that all of their tooling works with it. And that's the stage where once we tick all those boxes and we know everybody's good on DevNet, we can say, okay, we're ready for mainnet, and we can finally release Mesa to the world. And everybody's very keen about that too, because a lot of work has gone into this. Our teams are really proud of what we've done, and we want to see it out there. We want you to enjoy it too. I think that's it for me. So thank you all for listening. Hopefully we have some very important updates for you very soon. Thank you.
Thanks, Alan. I've just brought George up to the stage, who's going to give us the next update, some of the testing. So George, I'll hand it to you.
Hello, my name is George. I'm technical architect at o1Labs, and I want to very quickly run you through what kind of testing we ran while running this MUT program. So like there are different kinds of testings that we're running, in fact, and I won't cover all of them. And I will cover what was automated the most and on what we relied the most for actually ensuring that the release is good. For people who were participating in the program, you remember that you were providing some special flags to configure your node to be operated in an automated way to ensure that they produce some load for the network. So this was mostly like a black box, not like really a black box. We have some docs for that, but I want to just peer a little bit more into what happens under the hood. Next slide, please, Becky. So all starts with a screenshot on the left, which is completely unreadable. I'm sorry for that. But basically, there is a simple interface which is available for us internally. Basically, there is a huge JSON, which is not really a huge JSON, just maybe normally like just 50 lines of code, but 50 lines of JSON configuration. But basically, there is a JSON which specifies, hey, let's start this kind of experiment with this number of transactions per second. Transactions should be of this source, like payment or Zeko apps, or maximum cost transactions, which are also Zeko apps, but specially crafted Zeko apps. You configure that, and then you click submit. And then when you click submit, what happens, like the automation that is configured at our site, is that it can redeploy the network with a different commit if that is necessary. If that is not necessary, then it will simply start running the experiments, and it can run a few experiments with completely different configuration in a row. And record the results where it goes. So we have that screen. We have integration with our, there is a special Slack channel to monitor this, and we're using this extensively. Like there were, I don't know, at least 30 runs since this latest stage of this tooling was available, and many more since it was first prototyped. And during these runs and launches, we basically were doing more or less the same thing, running the test, checking some stats. I will cover on the stats on one of the next slides, and seeing whether it all makes sense. And if it doesn't make sense, then we probably have a bug or a performance regression, and then we still have to go a few loops before calling it a. Next slide. So the architecture of the tool, well, there are actually at least 6 different components, major components in this. So I simplified it a little bit. And so the main part is that you have some orchestrator component, which is sending transactions, generates transactions. It's called sequencer here, but yeah, I updated the slide a bit later. It's a bit outdated. But anyway, it sends, it generates transactions. If needed, it can redeploy the cluster. It submits updates to Slack as well. But what most importantly is that it is able to contact different nodes in the network and ask them to generate certain kind of transactions for a period of time. So something like generate payments for the next hour at this rate, go. So this is one thing that orchestrator does. Another thing that orchestrator does is it can contact some of the nodes and ask them to restart or restart with a full cleanup of the state of the network that was stored on that node. What happens when we click that submit button from the Sphere screen is that this orchestrator processes this configuration and then generates a long sequence of steps, and then it's running step by step. And steps might be find some online nodes and restart 10% of these nodes, or start generating of payments at this rate. So it is then running for a bit of time. And at some later point, we can observe some statistics, some metrics. Metrics gathering is fully separate from orchestration. So we don't orchestrator doesn't really care how the experiment runs. It will generate the prescribed load, and it will try as hard as possible to do that. And it will not read how the network behaves, because how the network behaves is the result of experiment that it wanted to separate these two. And let's talk about results on the next slide. So, and at the end of the run, there is another screenshot, which is probably unreadable on the screen, but at the end of the run, we have a few screens with tables on the left, where this is the main table. Basically, it shows that the experiment was running through a few rounds, and then for each round, you can observe how many transactions per second of different sorts were generated. And most importantly, you can observe what was latency of inclusion. So here, all of the latencies are well within an hour, actually well within 30 minutes, I think. So this is a good round. A good round meaning that for the target loads that we were applying in this round, the network was properly configured, and nodes are handling it well without any issue. It's possible to also test something like in a very stressful scenario where you assume that not all of transactions will be passed through, and we tested that as well. And then you will see latency spike to 2 hours sometimes. And this is specifically a test that is specifically arranged that way to see some transactions being not included for a long time. And then we have different metrics. Here is one that was more important for us for this release in particular, which is RAM usage. So we can observe RAM usage for Mina node split by components. And here the plot is interesting because like it captures when we started the experiment and then some time after it ended. So like you see it's growing, then it's short plateau, and then the experiment ended and it starts to descend like first very quickly and then somewhat more slowly. So this is like the expected behavior, and if there would be some spike somewhere in between, or it would be growing much faster, or it will grow beyond certain values like 18 gigabytes for this configuration, it would like bring some alerts and we would investigate. Next slide. And this one was, by the way, from MUT that we just ran. So what it gives us, we have a tool for regression detection. This is one purpose of it. And then when we are preparing a release, very often like we are changing configuration. Like for example, in this release, in this hard fork, we are switching from slot time being 3 minutes to 90 seconds. So we like a lot of small configurations changed because of that, and we had to like understand what is the new configurations that we need. But also we wanted to test like with more or less realistic simulations that this configuration actually makes sense even when the network is under load. So these two work well. Like this whole setup, it was completed to the current stage only only recently, last fall. But like we had these two links initially drafted for Berkeley, and when it was Berkeley, we were running this manually, which was good, like as a final gate. But here in Mesa, we actually used it a lot during the development process. Still not it was still kind of effortful to run experiments at early stages of Mesa development. But what we plan to do for the next release is that we actually will have a weekly CI when this regression test will be running. So for the next release, it will be more predictable for us, like what are regressions that we need to tackle, and hopefully we'll just tackle them immediately as they appear in the code base, rather than closer to the release. So that was it, and thank you for listening.
Thank you, George. We will be sharing more results from tests, and we'll share some of the insights from the retro in the coming weeks, so you'll be able to kind of learn more about this as well. I'm going to bring up Haresh now, who's going to share some ecosystem updates with us. Hey, Haresh.
Hey, Becky. Thanks. So starting with the ecosystem updates, I'd like to speak about the two audits that are ongoing. So Nori, which is a Zk bridge from Mina to Ethereum, is undergoing an audit with the Zelek team. I'm also happy to announce that the Frost multisig wallets audit has now started with the Veridis team. Moving on to wallet, the Clorio Connect wallet is now available on the Chrome store. So if you're listening, you're watching, please go try it out and provide your feedback into the Discord channel. The Ledger app, which supports Zk app signing, is now also available on the Ledger Live store. The Mina wallet provider API, the standard is now approved by both wallet teams, Oro and Clorio, so they should be looking to implement this in the coming weeks. Moving on, Zekanoid team hosted 3 tournaments for their Wizard Battle, which saw a participation of 313 players and over 2,000 battles were played. So I hope if you have tried it out, we'd love to hear from you. And also from the ecosystem side, there are a number of other projects which we are supporting behind the scenes, and that's all from me. I'll pass it to Becky.
Thanks, Haresh. I'm going to bring up Zeko now, who is also going to give an ecosystem update. So I will bring Evan and Martin to the stage. Hey, Evan. Hey, Martin. How are you both?
Great. Can you hear me?
Yep, can hear you perfectly.
Wonderful. Hi, everyone. I'm Evan, CEO of o1Labs. We are really happy to be working closely with o1Labs to prepare for our mainnet launch. So as you can see, mainnet launch is imminent. You're probably familiar with Zeko. We're a ZK rollup that's isomorphic to Mina. Zeko inherits the main benefits of Mina, the same cryptography, and uses o1.js. It adds speed, flexibility, and scalability to what the underlying Mina L1 can support. So it enables a different type of user and use case, and we're excited to bring it to mainnet. So you can get started on testnet now with the faucet. We're doing some of the final trustless bridge testing work, and then we'll announce that mainnet is live. So it's a very exciting time for the entire ecosystem. Check out the docs.zeko.io and our Discord channel to chat with the community and the team. You can launch an app similar to how you would on Mina. We have a whole variety of demos, boilerplate examples, tooling, SDKs, CLI instructions, and agent skills for your coding agents to bring you up to speed quickly. You can also run your own rollup with Zeko. So we have we can support infinitely deep rollup stack. All the docs on doing that and the Docker Compose are available. You can fork and deploy your own fully private order book DEX. That's one of the examples, or a private prediction market, or an AI agent protocol, and much more. So, a lot of these types of applications are getting funded in major ways, and we're excited to bring this to the Mina ecosystem and beyond, because as I'll talk more about later, Zeko is now connected directly to Ethereum base specifically for USDC payouts. So anything that is proven on Zeko can trigger a mainnet USDC transaction. So anyone can get paid utilizing Zk under the hood for any kind of verifiability or privacy. And Zeko brings instant transaction confirmation, scalable TPS. So all of your testing, the DevX is very fun. You can iterate and launch applications so quickly on Zeko. Please try it. You'll enjoy it. Your development timelines are reduced by 95%. So, plug your agent into the docs and get started. We really hope this unleashes a new wave of activity and new uses for CK. I'll hand it over to Martin, and then after I'll come back and we can talk more about a recent AI agent deployment on Zeko, so you can see one of the use cases. So over to Martin. Martin's our CTO. He's been building Zeko since about 3 years ago. He'll talk a little bit more about mainnet, our path to mainnet, and he can answer any deeper tech questions as well. Thanks. Over to you, Martin.
Yeah, thank you, Evan. Hello, everyone. I think I can shine more light on what we've actually built over the years on Zeko and what our Zeko rollup actually entails. So first thing I want to emphasize is that Zeko is not just Mina deployed somewhere else. Like, we are trying to remain compatible with Zk apps and making it isomorphic, but we can think of it more like we are building on the foundation that is already there. So like very lightweight verification, recursive proofs, and taking those core strengths of Mina and making them more practical at scale. One thing that we've been working most is the Mina's execution, scaling the Mina's execution model. The throughput of the layer one is somewhat limited, so we try to address this in two ways. One would be scaling horizontally in terms of one rollup. So like we have dynamic scaling based on demand. So the fees remain low, and we can scale the program network based on the demand, and therefore having a scaled rollup. These all would be still limited, but by the data availability layer, but the data availability layer has much higher throughput compared to layer one, because it's a multi-sig of trusted parties in the ecosystem. So we can scale the throughput much higher. And even if that throughput would limit us, we can still scale horizontally based on by spinning up new rollup instances. So we can have infinite, or like almost infinite instances of Zeko rollups that communicate with each other and scale Mina horizontally. So if you think about blockchain sharding, then this just has become available to Mina. This brings me to bridging. We solve bridging in a very general way. So our protocol heavily built on how Zcaps work, on how account updates for us are constructed. Essentially, you can bridge any kind of information from one layer to other layers. So any kind of transaction, state, action, even events, you can bridge to other layers. So not only like currently we have the UI for bridging funds, so you can witness that you've sent funds on one layer and you can unlock them on the other layer. But this is very general protocol, and it unlocks stuff like, I don't know, maybe cross-layer dexes and stuff like that, because you can make add order to the order book in one layer and you can witness it on the other layer, and you can bridge that. So it also unlocks a lot of possibilities for developers to explore and maybe build something interesting that is cross-layer and really builds on this blockchain sharding kind of idea. So just to share more on the DevX, also the thing that we have instant confirmations and you don't have to wait for block times and the fees are lower. It also makes the DevX much better. And yeah, we already are very close to mainnet. We have a final version that we are testing. We already have a code freeze, so you're very close. You can try it out on testnet and let us know. Thank you. Bye.
Thank you. And so what's next? We have mainnet launch, which is exciting. We've also begun to deploy Zeko to Ethereum natively. You can read the technical light paper on our website. We've started this development journey. So Ethereum L1 and other chains can have their own native Zeko rollups. Again, utilizing Mina cryptography and o1JS as the smart contract layer. So this brings o1JS to a much wider audience. It opens up new use cases, being on Ethereum, and exposes Zeko, Mina, and o1JS to this massive developer ecosystem. And that's one tenet of Zeko is empowering developers and expanding the developer ecosystem. So we're excited to also embark on this journey, which is beneficial for the whole community here on the call. I can take a minute to talk about a use case that's on Zeko. If you could go to the next slide. This is Santa Claus. Takes inspiration from OpenClaw, as you can derive. So the website is Santa Claus, spelled as you see here, .ai. It's live. It's an autonomous agent coordination and payment protocol. If you're running a local agent, you can now deploy it as an internet native worker. It's able to accept jobs via a public URL, and the system ensures the end-to-end process is machine readable, so your agent can manage it autonomously, and it's fully verified on chain. The agents agree on price, work, output. The work is commissioned. The seller delivers the artifact like an analysis report or an image, and the buyer then pays the seller using ZK X402. So your agents can now run on a ZK powered system, and then they receive USDC on base mainnet for their work. So you can make real money. It's very fast. There's agents that are live. You can get your agent live too and start making money. We released this about 2 weeks ago. There's dozens of agents. There's about $1,500 in payouts already. So we're excited to scale this further. And importantly, from a design standpoint, and UX standpoint, which a few other folks have spoken about, this completely abstracts away the entire ZK part. So there's no Zeko wallet, there's no RO. The agents don't need gas for Zeko or base. You just type in your agent name, and then you enter the base mainnet wallet. And so the sign up takes 1 minute, and then the agent can work 24/7, hireable by anyone in the world, and everything is anchored and verified using ZK and on Zeko. So it's a powerful new kind of design space and implementation that shows what ZK can do for unlocking use cases that a lot of the world really cares about right now. So yeah, check it out. And we're excited to scale this together. And we hope to see all of your agents onboarding and doing cool work, because there's so much out there, from code audits, image generation, consulting reports, you name it. The world needs intelligent agents to be fully autonomous and using a ZK system underneath to power all of it. So thank you. That's an update from Zeko.
Thanks, Evan. Thanks, Martin. You can learn more about it and follow the team on X and I think in Discord as well, right, Evan?
Yes. You can join our Discord through our website link.
Perfect. Thank you so much. Thank you to everyone for joining today. That was the last of the updates. This is recorded, so you'll be able to find it on YouTube afterwards, and you can find it on X. We'll also share a recap over the next few days. We look forward to seeing you in episode 3. See you next time. Thanks, everyone. Bye.